Geometry Chapter 8, number 105. A regular hexagon with a side length of 4 has the same area as a square. What is the length of the side of the square? Explain how you know. So, what I'm going to do is I'm going to find the area of the regular hexagon and then set that area of the regular hexagon equal to the area of the square, which is just side squared, kind of the side. So a regular hexagon is a side length of 4. Okay, so I'm going to jump to the part where we have this triangle, and there's 6 of these because it's a hexagon. Right? Each of these is an equilateral triangle, so that's 60 and 60. This is the height here of that equilateral triangle. The side length of 4, so that's 2 and 2. That's 4, that's 4. These are 30, 60, 90 triangles. I realize I'm going through this pretty quickly, but we've seen plenty of these by now. I should be able to kind of, do this in our sleep here. So hypotenuse is 4, short side is 2, long side is 2 root 3. So the area of one of these triangles is 1/2 times the base, which is 4, times the height, which is 2 root 3. So this is 2 times 2 root 3, which is 4 root 3. But there's 6 of those. So 6 times 4 root 3 is 24 root 3. So that's the area of the hexagon, which means that it's also the area of the square. So 24 root 3 equals the side squared. So in order to find this side, we're going to have to take the square root. So we have 24 root 3, and then the square root of that equals the side length. This probably isn't a very appropriate way of writing it. The square root with a square root underneath it. So I would probably just, if I was writing this as an answer, you would probably be expected just to leave it as a decimal. So whatever 24 root 3 is, plug it in your calculator and do the square of that to get the side. I don't have the calculator in front of me, so I can't really figure out what that particularly is. So I wouldn't expect you to leave it like this or try and simplify this down using radicals. But nevertheless, we found the area of one of these triangles in the hexagon. Took the area of that triangle, multiplied it by 6 because there's 6 of these triangles in the hexagon. To get the area of the hexagon, set that area of the hexagon equal to the side squared, which is the area of the square, and then took a square on both sides to get that length. If you have any questions or comments, please feel free to leave.